Hi, my name is Brian Adler and I'm a Solutions Architect here at RightScale. In the next few minutes I'm going to give you a brief presentation of the RightScale Cloud Management Platform. We hope to show you how RightScale makes it easy to deploy and manage your applications in the cloud. Through the course of this presentation, I'll show you how you can get your apps onto the cloud fast with our cloud-ready solutions, how to architect systems to self-configure and adapt to system changes like increased demand or failures, how to manage at a systems level, how to manage users and control costs, and even codify your learning to share with others. And of course, with RightScale, you preserve future options. Our management platform enhances your application's portability, and that it works with a number of cloud infrastructure providers, including Amazon Web Services and the Rackspace Cloud. It also works with private and hybrid clouds, utilizing technologies from Eucalyptus and VMware. To begin our discussion, let's take a look at a typical use case. This diagram shows a standard 4-server architecture that many of our customers use in early phases of the application lifecycle. It has 2 front-end servers that are configured to act as both load balancers as well as application servers. This allows each server to send traffic to its own application server as well as to the application server running on the other front end. DNS entries are configured such that both of these front ends respond to requests for the same website, for example, yoursite.com. Now behind the public-facing side of this configuration, we have a MySQL master database server and a MySQL slave server. Each of these MySQL servers has an attached volume that they use to store the production database, as well as connections to a repository where they regularly upload snapshots of that database. As this architecture becomes more complex, you see that the number of components involved grows and the interactions between those components becomes more complicated. Now what I've drawn here is actually a fairly simple architecture, so you can probably imagine, or perhaps you suffered through the pain of, the complexity involved in managing a more intricate system. To use RightScale terminology, the set of servers and the interrelationships between them that I've diagrammed here is what we call a deployment. Now deployment is simply a collection of servers that work together to achieve some common goal. In this case, the ability to serve up a web-based application. Now servers within a deployment can share input variables, cloud configurations, etc., or they can be set at the individual server level, and we'll take a look at that later on. In the dashboard, you see all the deployments of an account. I can use the dashboard to easily manage, maintain, and control all the deployments in my account, as well as all the servers within those deployments. In this particular deployment, you see the collection of servers I previously diagrammed, with the addition of the load tester server, which we can ignore for this discussion, and then it's simply used to simulate traffic to the site. Let me point out a few interesting details on this screen. You can see each server is represented by a server template, which is a unique feature of the RightScale platform, and we'll discuss in more detail in a few moments. Both of the front-end servers are based on the same server template, as are the MySQL master and slave servers. The set of inputs that are provided to each of these server templates during launch are different, and that is what allows the server to configure itself correctly during boot. So, if it's an application server, it knows how and where to access the bits and pieces it needs to configure itself and behave as an application server, including the name of the master database server it is to connect to, as well as the information it needs to connect to and register with the deployment's load balancers. Also notice the cloud column here in the dashboard. As you can see, front-end number 1 is running in the Amazon EC2 US cloud, while front-end number 2 is running in the Rackspace cloud. From a cloud manager perspective, these servers are just front-end servers. The fact that they are running in different cloud infrastructures is irrelevant. In addition to being able to view all the servers in your deployment and centrally manage their input variables, you can also monitor entire deployments. By clicking on the Monitoring tab at the deployment level, you have the ability to view graphs of any of the collected metrics on any of the servers in the deployment. For example, here you see several graphs from the MySQL master server and both front-end servers displayed in this same view. By selecting this pull-down menu, you can select any server in the deployment, and then any graph associated with that server, and add it to this same view. Additionally, here in the Quick Monitoring section in the upper left portion of the dashboard, you can see that I have thumbnail versions of several monitoring graphs always visible. I use this for the metrics on specific servers that are of particular interest to me. For example, here we see the number of Apache requests that are hitting the server named Front-End A over time. By clicking on the thumbnail graph, I can bring up a larger version with more detail. As this graph shows, the number of Apache requests hitting this box is pretty predictable. The reason being we are using a CAN script to generate the load from that load generating server we talked about earlier. You can add up to 8 graphs to the Quick Monitoring section, and they will be available regardless of what screen you are on in the dashboard. Another benefit of the RightScale platform that ties in with monitoring is alerts and escalations, which we'll take a look at next. With the RightScale dashboard, you can create alerts and associate them with your deployments.
Here we see the alerts that have been configured for this particular front-end server. On the screen you also see the escalation column, which shows a particular escalation activity associated with each alert. As an example, let's take a look at the scale up escalation activity, and you'll see that its action is to vote to grow the array. This will result in additional instances being added to the array of application servers that are handling the traffic load for this site. Escalations can also perform other user-defined actions as well. For example, for this low space in root partition alert, the escalation has two actions. The first is to send a simple email to a specified user, and the second is to run a script to try to perform some corrective action. With RightScale, you determine what actions are taken for each escalation, a simple email or some sort of automated action.
Okay, so that's a fairly quick overview of all the moving parts involved in monitoring, alerts, and escalations. And as we discussed previously, the really cool aspect of all this is it's all automated for you. Once you set up your server templates, your alerts, and your escalations, your deployment automatically adjusts to changing demand and system failure. Earlier we also touched on the concept of server templates. Server templates innovate beyond simple machine images in that they allow you to automate and configure servers without the time and hassle and inflexibility associated with bundling instances. Let's take a look at a typical server template, which will help to illustrate their key concepts, benefits, and features.
What we see here is a server template that is used by the two front ends in the deployment we've been using throughout this demonstration. The value of server templates are twofold. First, they're used to support automation through the RightScale platform. Server templates launch servers that configure themselves within the context of a deployment and without any human intervention. Consider all the manual steps required, for example, to configure a server to register with a load balancer, or to grant it the proper credentials to access a database. Using server templates, all these steps are taken care of for you automatically. Another benefit of server templates is that they are portable and help to prevent cloud lock-in. The same server template can be used to launch a server in multiple clouds. Let's look more closely at this particular example to see how server templates deliver on both these valuable benefits. A server template has three basic components. The first is a machine image, which is in essence the bare OS essentials needed to get the instance operational, with the addition of some RightScale hooks to allow it to communicate with the RightScale platform. In this example, you see a cloud portable template that uses an Ubuntu 8.04 image in the EC2 cloud and an Ubuntu 8.10 image in the Rackspace cloud. To further illustrate the cloud portability of this template, we can see that all we need to do is click the launch button, and the first dialog we are presented with is a pull-down menu listing all the clouds in which we can launch a server using this single server template. The next server template component is a set of cloud configuration information, which describes for each of the clouds this server template can operate in all the relevant cloud-specific information, such as the instance type and any user data that needs to be supplied to the server. RightScale maintains these configurations for each cloud, so you don't need to worry about the underlying cloud infrastructure, just the server's role and function within your deployment. The last component of a server template, and the one that truly unleashes the flexibility and customizability of the servers launched from that template, are the scripts and/or recipes that are used at boot time, during operation, and during server decommission. There are currently hundreds of scripts and recipes developed by RightScale, our partners, and others in the RightScale community that you can use to configure your servers or that you can leverage to create your own. Each of these scripts has its own unique set of inputs, and as we mentioned earlier, it is with these inputs that you can configure unique servers from the same server template. It is also these inputs that allow the server to configure itself in the context of the larger deployment. For example, here you see the lb_hostname input, which is the hostname of the server in which the load balancer application is running for this deployment. When an application server is launched from this template, you supply this hostname either manually or it can be set at the deployment level, and it will be used by all the servers in the deployment. This server will use that hostname to connect to the load balancer and automatically add itself to the load balancer pool. It does this without any system administration support, thus enabling true automation. Now that we've delved a bit deeper into server templates, let's spend a moment talking about maintaining systems over time and the application and system lifecycles. The RightScale platform provides many features and functions that assist you in all phases of the application lifecycle. One of the more powerful and unique functions is the cloning capability. Let's look at the scalable photo site deployment to illustrate this feature. Here in the upper left of the dashboard, you see the clone button. Within the RightScale dashboard, you have the ability to clone entire deployments with a single button click, which I will demonstrate here. The end result of the cloning process at this level is a separate deployment with the same servers based on the same server templates using the same cloud configurations and inputs. This feature of the RightScale platform greatly increases the agility of your business and ensures repeatability. Cloning is a very powerful feature of the RightScale platform that many of our customers use to create staging deployments from test and dev deployments, and then production deployments from the staging deployment. A common way to accomplish this is to clone a deployment, as I've just demonstrated, and then adjust a few server inputs pertinent to the new deployment. For example, resetting DNS configurations or pointing application servers at the true master database as opposed to the staging master. Compared to the traditional method of migrating from a staging to production deployment, the process often takes less than 30 minutes or so, compared to many hours or even days. Another task in the lifecycle of an application is to update servers with new versions of code. The RightScale platform greatly decreases the complexity of this process because you can quickly and easily run a particular script across all servers in your deployment or all servers in an array. For example, if you rolled out a new version of code and you want all of your application servers to download that code, install it, and then point their document route to a new location, you don't need to do this one server at a time and result with servers out of sync with respect to the versions of code. You can write a single script to accomplish this task and then run it across all the relevant servers at the same time. Here you see an example of running a script at the deployment level. The script I've selected is only relevant to the front ends, so they are the only servers shown in the list of servers on which I can run this particular script. All this requires no change to the server template. You simply choose to run a script across all servers at the deployment or array level. This again ties into one of the key benefits of the RightScale platform, the ability to manage systems and not just servers. We've just seen how you can manage at a systems level, monitor and automate deployments, and maintain them over time. Lastly, before we wrap up, I want to briefly talk about cloud best practices and user and account management. As you and others in your organization build your stockpile of server templates, scripts, recipes, and deployment architectures, all this is being stored for you in your RightScale account, thus becoming a best practices repository for your organization that you can reuse or share with others. Also, as more people in your organization use the RightScale dashboard and the tools it provides, you have the ability to manage permissions and costs by creating child accounts within your organization's master or enterprise account. With this enterprise account, you have greater visibility and control of the usage and activity of your child accounts.
To conclude, this brief presentation has just scratched the surface of what you can do with the powerful RightScale Cloud Management Platform. We talked about how you can use RightScale to dynamically configure cloud resources across multiple cloud infrastructures, and how to manage, monitor, automate, and maintain entire systems, or what we call deployments. We touched on how you can control and manage users and costs, how you can codify your corporate best practices as you delve into deploying applications on the cloud, and how you can maintain portability and avoid cloud lock-in as you leverage the existing tools that we have in place to facilitate cross-cloud and cloud-agnostic architectures. Thank you very much for your time and interest in RightScale. From here, I suggest you try it for yourself and sign up for our free edition or attend our live weekly demonstration, both of which are available at our homepage at rightscale.com. You can contact us via email at sales@rightscale.com or by calling us anytime at 866-720-0208. Thanks again from all of us here at RightScale, and we hope to hear from you soon.